Cool, right, 12.3, trig graphs. So, relatively short lecture today, but it is a really, really important one because we're going to base the whole of next week's trig on these graphs. So you need to learn these. So first up, okay, so start by sketching sine from 360 degrees to minus 360. You guys might want to draw this a bit more accurately for the first time you're drawing these. The sine goes from -1 to 1. So sine comes up, it has a maximum at 90 degrees, goes through 0 at 180, minimum at 270 and then back up. So if you want to put these in as well. And then that kind of mirrors, so we get the same kind of thing, goes back through 0 there. Not too bad, you should have the same peak size. But yeah, it goes up to 1, goes down to -1, peaks at 90, minus 270, 270, minus 270, minus 90. So that's sine. Cosine, cos x. The cos is a lot like sine, same shape, but it has been shifted. So again, up to 360 and down to minus 360. So cosine starts at 1, has a minimum of 180, and then goes back up to 1, 360. And that mirrors again, so down through 90, minimum 180, and back up. So 90, and sine, cos should be completely symmetrical. That's actually a lot better now. Cool, and last one is tan. And tan's a weird one, tan has asymptotes. So there's an asymptote at 90 and at 270. And at minus 90 and at minus 270. So if I put those in. And tan kind of goes up to those asymptotes. And tan passes through 0. At 0. That. So there we have sine, cos and tan. Make sure you've drawn these accurately. Pause the video if you need to, have a look at them. And plot them on, actually don't plot them on GeoGebra, because GeoGebra won't be in degrees. Yeah, so here we go, always from 360 to 360, unless it tells you otherwise in the exam. Right, so we need to be able to transform these. So if you keep these handy, we're just going to go through a few examples of how we can translate these different graphs. And then next week we're going to be using these to solve things. And they're going to be a key part of what we're doing. Cool, right, we're going to try through these. If you guys want to pause it, you can. All these bits here is telling you what range of values to draw it for. So here we're going to do the full 360, 360. Here 0 to 360. And here minus 180 to 180. So pause it, have a think about what each of these transformations does, and see if you can sketch them. Right, so first of all we're going to do cos x plus 1. Now if you're a mini sketch of what cos looks like, we're going to move the whole thing up 1, so all of it's going to sit on the axis. No, that's going to be horrible to draw. So it's going to go up to 2, so you're going to go down to 0, so we don't actually need any negative anymore. And if I cheat and kind of put a dotted line in, it'd be a lot easier. Get rid of the line. So 360, 180, minus 180, minus 360. So that's what that should look like. Next one, 3 sine x. So it's still going to look like sine, but we've stretched it. So draw sine and relabel it. 3 and minus 3. Minus tan theta, so that's outside the function. So there's a reflection of the y values in the x axis. So it's going to end up looking like this, and then that will take us up to our range of 180. That's crazy. So there you go, so you need to be good at transforming these things as well. Right, last bit we need to do this week is looking at equivalent values, which is going to tie in with what we're doing next week quite closely. So we're told cos of 30 is root 3 over 2. That's a fact. We're trying to find another value of theta for which cos of theta equals that. So the way we're going to do this is to sketch cosine. And remembering 180, 360, 270, 80, minus 80. So, we're told cos of 30 is root 3 over 2. So if you find cos of 30, 30 is about here. So that's going to give us that value. So any other value will be in the same place on the graph. We can do a pencil. Great. Cool, so cos of 30 is I was saying we could assume it's there, and that value there would be root 3 over 2. So, where are the other values that are equivalent? So there's going to be another value here that's equivalent, another value here that's equivalent, and another value there that's equivalent. And the way we're going to find these is really important for what we do next week. So we're going to measure the distance of this angle from the peak. So the peak is at 0, so our value we want is 30 degrees away from the peak. So it makes sense that this value will also be equidistant because it's symmetrical. So we can say another value theta can be minus 30, which is this one. We can find this one as well, so the peak is at 300, so it's going to be 30 away from the peak that way. So that's going to be 330. Or we can do the same over here. Here's the peak, 30 away from the peak, so it's going to be minus 330. So all these values are equivalent to cos of 30 and they all equal root 3 over 2. If we type in cos of any of these in a calculator, we get root 3 over 2. So trig equations can have multiple solutions. Right, let's try one more of these. So find all the values between 0 and 360 for which 2 sine squared theta equals 1. So, we can rearrange this and get sine squared theta is a half. And you get sine theta is the 1 over root 2 plus or minus. So that's what I'm trying to solve. So inverse sine of 1 over root 2, which gets you 45 degrees. And if we do the same for minus 1 over root 2, we get minus 45 degrees. So we've got to find all the angles equivalent to 45 and minus 45 that are between 0 and 360. So if we sketch sine, put the angles in as well. Cool. So first angle we need to find is 45 degrees. So that's going to be here. So I can tell there's going to be another value there which we need because these are both between 0 and 360. And minus 45 is here. So there's 2 again that are between 0 and 360. So although we started with this one, it's not going to be one of our final answers because we need it between 0 and 360, but these two are. So our first angle was 45, and that was measured from where it crosses the axis. So this one here is going to be measured from where it crosses the axis, as is this one here, as is this one here. So we're going to get 45, we're going to get 180 minus 45, so that's going to be 135. We're going to get 180 plus 45, which is going to be 225. And we're going to get 360 take 45, which is 350. So there are 4 angles between 0 and 360 for which sine squared feature is a half or sine feature is 1 over plus minus 1 over root 2. So next week when we're solving trig equations, sketching them in order to find all the different equivalent angles which solve the problem. I should try one more of these and get you guys to... So trying to find all the values of theta between 0 and 810 for which sine of theta equals half. So if you guys want to pause it and give it a go. First step will be to find our first angle. We call it the principal value. So you sine to minus 1, arc sine of a half. And that's going to give us 30 degrees. So our principal value is 30. We want every corresponding value that is the same as 30. So I'm going to sketch sine from 0 to 810. Bear with me. So we're going to get, that's up to 360. That's going to take us up to 720. And then another 90 degrees will take us to 810. Cool, we can try and fill in the rest of these. So 180, 540, yeah. And then the ones in the middle, so 90, 270, 450, 6, 30. Yeah, there we go. Right, so sine equals a half, and we can find a half quite easily because this goes up to 1, a half's going to be here, so there should be 1, 2, 3, 4, 5 of these by the looks of it. First one we're told is 30 degrees, so that's this one. And we're measuring it from where it crosses the axis here. So this one's going to be 30 less, this one's going to be 30 more, 30 less, and 30 more. So we get 30. Here 180 take 30, which is 150. 360 plus 30, 390. 540 take 30, 510. 270 plus 30, 750. So those are all the values for which sine feature is a half. We can test each of those on a calculator. Sine of that's a half, and that, and that, and that, and that. All gives you a half. Cool. Right, make sure you're happy with that, guys, and we'll be doing a lot of practice on this next week and using this the week after when we look at more advanced trig questions. Cool, thank you.